This is not just a future scenario. A smaller version already happened. In 2013, a house-sized asteroid came in over Chelyabinsk, Russia at about 11 miles per second. Most people had no warning. It exploded high in the atmosphere. Then the shock wave hit the city. Windows blew out, buildings shook, and people were injured by glass. NASA says more than 1,600 people were hurt, and that object was only about 18 meters wide. Now compare that with the class we are talking about here. A 140-meter object is not a bigger fireball. It is a different level of threat. So, Chelyabinsk was not the nightmare. It was the warning shot. The real question is, what happens when the next one is much larger? From out here, it looks almost simple. One rock, one path, one planet. But if that path lines up with Earth, that's all it takes. And down here, nobody would feel it yet. Traffic keeps moving. People go to work. Kids get dropped off at school. Everything still looks normal. Then that normal life is gone in seconds. That's what a city-killer threat means. Not the end of Earth, just the kind of impact that can tear through a region and change everything. This part is not a movie setup. NASA's own planetary defense material estimates about 25,000 near-Earth objects this size, and only about 43% have been found. That's the part people miss. The biggest problem is not the asteroid we already know about. It's the one we don't see early enough. Here's the part that makes this hard to brush off. That number is not pulled from a random headline. It comes from NASA's own planetary defense material. They estimate about 25,000 near-Earth objects in the 140-meter range or larger. That is the class big enough to cause regional devastation if one hits the wrong place. And only 43% of that group has been found. So the uncomfortable math is simple. More than half are still not on the map. That does not mean one is about to hit us tomorrow, but it does mean thousands of objects big enough to matter are still out there, moving through space while life down here keeps running like normal. And the number is only the first problem. The next problem is worse. Some of them are hard to see until they are already too close. The next problem is that some of these things are just hard to see. They do not need to be invisible. They only need to be dark enough. A big asteroid can look like a weak little dot through a telescope, and if it does not reflect much light, size gets harder to judge. Then there's the angle. If something comes from a bad part of the sky, especially near the sun's glare, finding it gets even harder. Ground telescopes are powerful, but they still deal with weather, daylight, the horizon, and a sky that is much bigger than any one search system. That's why NASA is building better eyes in space. CNEOS Surveyor is designed to help find dark asteroids that are difficult to catch from the ground. But here's the uncomfortable part. That better system isn't fully closing the gap today. And until the gap closes, late discovery is still the thing that scares experts. Here's the part that sounds comforting at first. NASA says no known asteroid has a serious chance of hitting Earth in the next 100 years. But that sentence has one word doing a lot of work: known. The real problem starts with the objects that are not in the catalog yet. Because once one is found late, science is suddenly racing against the clock, and the public will not wait calmly for perfect numbers. People want answers fast, but with asteroids, better answers come from more observations, and that takes time. So the nightmare is not just a rock in space. It is finding out too late while everyone on the ground is already trying to react. This is where the word city killer stops sounding like a headline, because the danger is not just the rock, it is where it hits. A larger object does not need to destroy the planet to change everything. If it comes down near the wrong city, the damage starts spreading fast. First comes the flash, then the shockwave. Glass, roads, power lines, buildings, normal things become dangerous almost instantly. NASA's own exercise material breaks this down into damage levels: serious, severe, critical, and in the worst zones, unsurvivable. And then the crisis moves through the systems people depend on: hospitals, traffic, electricity, water, emergency response. All of it gets hit at once. If the impact is offshore, the problem can move into the ocean. Then coastal cities are not just watching the sky, they are watching the water. And that is when the real question changes. Not can this cause damage? It can. The question is whether we would have enough time to do anything about it. This is why time more than most people think. A dangerous asteroid is one problem. A late discovery is a completely different problem. If we have years, there are real options. A spacecraft can be planned, launched, and used to push the asteroid just enough to miss Earth. But shrink that warning down to months and everything gets harder. You are still doing science, but now every decision has a deadline attached to it. Shrink it down to days and the mission changes. You may not be trying to stop the impact anymore. You may be trying to move people out of the way. That is when this stops being a space story. It becomes hospitals, highways, families, shelters, and decisions nobody wants to make. So the missing asteroids matter because time is the real defense. Find one early and you might have options. Find it late and all you have left is reaction. NASA is not pretending this problem does not exist. That is why missions like CNEOS Surveyor matter in the first place. The idea is simple: put better eyes in space, not to look for aliens, to look for dark objects that are easy to miss from the ground. Some asteroids do not reflect much sunlight, so instead of just looking for brightness, CNEOS Surveyor is designed to help detect their heat. The goal is to push detection much closer to the level we should have had years ago. But that goal also tells you something uncomfortable. We are not there yet. The missing objects are not waiting for the perfect telescope before they keep moving. So this is the part that should stay with you. Better detection is coming, but late discovery is still possible right now. The known asteroids are not the part that should scare you most. NASA tracks those. That is the good news. The bad news is what is still missing. Thousands of objects large enough to matter are still moving through space without a full place on the map. And that is what makes this different. The danger does not have to look dramatic at first. It can be out there right now, dark, quiet, and still unnoticed. So the real question is not whether the sky can be dangerous. It is how much of it we still haven't seen.